All right, for remembering factoring, I'm just going to do a little note off to the side, because when you're factoring something with a number in front of whatever's squared, for example, if I write this with x's so that it looks like something you're more familiar with, if you had 2x squared minus 3x minus 1 equals 0, and you had to factor that, it's always more difficult when there's a number in front to factor. So you might have learned some strategies in grade 11. There's like a grouping strategy. There's a couple of shortcut strategies. I'm not sure exactly all the different strategies you've learned, but one of the things that I want you to get to at a certain point is that you can just go directly to the factored answer. Yes? Yes, it is plus 1. Thank you. So I want you to be able to go directly to the answer. Well, in order to do that, I want to point out some patterns. So one of the patterns I'm going to point out, let's say you factored something else and it happened to be 3x plus 1 and x minus 2. If you multiplied this out, you would multiply the first ones, the outside ones, the inside ones, and the last ones, and you would get 3x squared minus 2x, minus 6x plus x minus 2, and you would combine your like terms and get 3x squared minus 5x minus 2. Now multiplying things out is easy, or easier. Going from here to here is much easier than factoring and going back from there to there. But there are some things that we can notice that can really help us in our factoring. First of all, whenever we multiply something out and combine those like terms, you should notice that whatever your first factors were, the 3x and the x, will always multiply to whatever your first term is. And whatever your last two factors are, the 1 and the minus 2, they will multiply to be your last one. And that's the first thing you're going to look at when you're factoring, because sometimes there is only one option. For example, in ours, if our first term is 2x squared, and this factors to be nice numbers, there's going to be some that don't factor nice, and you're going to have to use your quadratic formula. But if it would factor to be nice numbers, there's only one option for our first numbers. What's the only way you could get 2x squared? 2x and an x. If you have nice numbers, that would be the only option. What about your last one? It's a 1. What are your only options to multiply to get 1 if they're nice numbers? 1 and 1. And the last thing you're going to look at is, should the signs be positive or negative? Because your outside values and your inside values have to go together and give us negative 3 in this case. Well, since it's a negative 3, and they both have to be positive or both have to be negative, it makes sense that they're both negative, because now my outside is negative 2x, my inside is negative x, and that gives me negative 3x. So one of the things that we're going to be doing is we're going to be looking, when we factor something like this, we're going to be looking and saying, well, the only way to get 2 sine squared theta would be to have 2 sine theta and sine theta. And the only way to get 1 at the end would be to have a 1 and a 1. And then checking the outside and the inside, these signs will both have to be negative. So now that we've factored it and it's equal to 0, either this first factor is equal to 0, in which case sine theta would equal 1 over 2, or the second factor is equal to 0, in which case sine theta is equal to 1. It's 1/2 on our pie plate. What family? Close. Pi over 6. And since it's positive, you would look for answers in quadrant 1 and quadrant 2. Is 1 on your pie plate? Yes. What angle has a y coordinate of 1? 90 degrees, pi over 2. Excellent. So there's going to be some that when we go to factor them, we're going to have to think like this. This next example has sine and cos in the same equation. And one thing you would have learned from grade 11 is if you had an equation and it had two variables, you weren't able to solve. That's a line. You can graph it, but you can't solve for x and y because you have one equation with two things you don't know. For example, x could be 1, y could be 2. X could be 0, y could be 3. There's more than one answer at this time. But if I told you another equation, you would have two equations with two unknowns, and then you can solve it. Now there's only one solution. You learned graphically that those graphs intersect, and the point where they intersect is the solution. You learned techniques for solving this. Do you remember a substitution technique, an elimination technique? Does that sound familiar? So we learned those techniques, and we learned that if you have two things you don't know, you need to have two equations if you want to solve for it. Well, same thing happens now with sine and cos, but in your exam, they're just going to give you the one equation because your other equation is on your formula sheet and is one of our big ideas. We know that sine squared plus cos squared is always equal to 1. What that means is we could rearrange this to get sine squared by itself by subtracting cos squared on both sides. We could also rearrange this to get cos squared by itself by subtracting sine squared on both sides. And the reason that's going to be helpful is because we're going to use the substitution technique and rewrite our original equation, but instead of writing cos squared, so I've rewritten it except I took out the cos squared. What could I write instead of the cos squared? 1 minus, cos squared is equal to, so I would look at this one. Since cos squared is equal to 1 minus sine squared, I could write that in place. And if I do that, notice my new equation just has sine in it. So now I can solve this just like I solved the last question. I'm going to have to distribute that negative because I have brackets. Anytime you do a substitution, especially if there's more than one thing, you need to put it in brackets. And now if I distribute this negative, it'll be minus 1 plus sine squared minus 3 equals 0. This is a quadratic equation. I'm going to rewrite things in the order that we normally write quadratic equations. We normally write the squared first. So I have sine squared theta. Then minus 3 sine theta. I can put the minus 1 and the minus 3 together to get minus 4 equals 0. So now we have to decide, can I factor this? If I can't factor this, I'm going to need my quadratic formula. What's going to happen? So we're going to start by trying to factor it, because if you can factor it, it will be faster. Well, the first one is sine squared. What's the only way I can get sine squared? It's got to be sine and sine. My last number is a 4. It could be 1 and 4 or 2 and 2. We need to have our outside and our inside make 3. So should I use 1 and 4 or 2 and 2? 1 and 4. And then when deciding on the sign, I need a negative 3. So I'm going to need my outside to be a negative 4. So I get negative 4 sine theta plus 1 sine theta. So I get my negative 3 sine theta in the middle. We can split it up here. If this one's equal to 0, then sine theta is negative 1. If this one's equal to 0, then sine theta is equal to 4. Any values from our unit circle? Always do those ones first. Negative 1. When is the y-coordinate negative 1? 3 pi over 2. Is 4 on your pie plate? No. So if something's not on your pie plate, then you'd have to go to your calculator, find your reference angle, and then sine is positive, so you would look for that answer in quadrant 1 and quadrant 2. So I want you to take out your calculator. I want you to find the reference angle for that one. So we go to our calculator. We try to get our reference angle by doing sine inverse of 4, and we get an error. So then the most tempting thing to do is say, oh, maybe I was supposed to push sine of 4. And you don't get an error if you push sine of 4. But no, for your reference angle, you have to use sine inverse. But why do we get an error here? In fact, this question, even though 4 is not on your unit circle, would be a non-calculator question on the final exam. Because they're expecting you to know the reference angle and to know sine theta equals 4 and be able to solve that without your calculator. Well, what does sine stand for? Back to our right angle triangles. Opposite over hypotenuse. So let's just draw a little picture here. Let's make that into a fraction, 4 over 1. And draw a reference angle and draw a right angle triangle and make the opposite 4 and the hypotenuse a 1. Doesn't work. What do we know about the hypotenuse? It's always the longest side. So if you got any kind of fraction here or any number here that's bigger than 1, that'll never work for sine or cos, because the hypotenuse has to be on the bottom, and that has to be the largest number. So going to our calculator, we got an error with our calculator. On your test, this would be a non-calculator question. They would expect you to recognize that sine theta equals 4 is not possible, and you need to write something like not possible or no solution, something to show that you know that. If you just leave it blank, you lose a mark for clarity, because the exam marker doesn't know if you know that there's no solution or just didn't know how to do it. So you need to have some sort of indicator that you know on that side that it's not possible, that there's no solution. All right, part E. This one is a harder one to factor quickly. First of all, we need to make it equal to 0. We are going to factor this one quickly, but it's harder to factor quickly because when we look at our first one, which is 6 sine squared, there's more than one possibility. It could be 1 and 6 or 3 and 2. In cases like this, where the first one gives you more than one option, look at your last one. Do we have more than one option with our last one? No. The last one, because it's a 1, has to be 1 and 1. So I would start with something that you know for sure. There are cases of factoring ones where both the first and the last one have more than one choice. Then those are the ones where your grouping strategy you may have learned in the past is a good strategy to use. Or you just randomly pick one and check to see if it works. And if it doesn't, you go with the other one to see if that would work. But because our last number is 1 and there's only one option for that, has to be 1 and 1, now we can look at, should it be 6 and 1 or 3 and 2? Especially when thinking we need our outside and our inside to make 1 in the end. Three and 2. And one of them needs to be positive, and one of them needs to be negative to get the negative 1. We want a positive sine theta, so we would want our 3 to be positive, our 2 to be negative. And so it allows us even to factor these tough ones really quickly. After we solve this, I'm going to re-show you the grouping method because I've been talking about it and you're like, yeah, I kind of don't remember that either. So I'll re-show it to you so you can see it again. But we'll be, for the most part in grade 12, the factoring isn't complicated, that you can do things directly fast like this for almost all the factoring ones you need to do. Anyways, at this point, this one, move the 1 over, divide by 2. This one, if it's equal to 0, move the 1 over, divide by 3. Can you see that both of those fractions are less than 1? 1/2 is on your pie plate. What family? Pi over 6 family. And since it's negative, you'll have quadrant 3 and quadrant 4. 1/3 is not on your pie plate. So here you would have to go to your calculator. Our question, all of these questions we're solving between 0 and 2 pi. That means our calculator would need to be in radians. Your reference angle is always sine inverse of the positive value, and it's positive already. But just a reminder for that. You go to your calculator and you get what? Yes? Okay, good. So now there's our reference angle. Sine is positive. Which quadrants is sine positive in? Quadrant 1. And in 2, how would we figure it out in 2? We would go, well, if it was degrees, we'd go 180 minus our reference angle. Since it's in radians, we would go pi minus our reference angle. And of course, you'd use your calculator for all of that. So there's an example where part of it would be non-calculator and part of it would be calculator. These questions, when they're written on your final exam, they happen in the first 6 questions of your exam, because those are the only calculator questions on your exam. And the way that they would word this is they would say, write all answers as exact values where possible, or round to 2 decimal places. So what they're saying, exact values where possible, this side they expect you to make sure you write the exact values. This side where you can't, you would write them as decimals. I said I'd add one more question. I chose tan because if we get an answer bigger than 1 for tan, that's okay. You can have the opposite divided by the adjacent be less than 1 or bigger than 1. I also chose this because right now I can see some of you are looking at it, you're trying to factor it, and it's not working. So you're trying to factor this one, but it doesn't factor. So if you can't factor something, you're going to need to use quadratic formula. Quadratic formula is on your formula sheet. But here, we don't have an x. What do we have instead of x? We have tan. So when we write out our solution, we'll write tan of theta equals negative b plus or minus b squared minus 4ac, which will end up being plus 20 over 2 times a, which is just 2. And we're going to need to put this into our calculator. When putting this into our calculator, I would use the fraction button because we have more than one thing that we're entering. We've got a -1 plus the square root of 21 over 2. That will be one answer, 1.79. And we would do the minus for the second answer. I'm going to show you a couple shortcuts with your calculator. Instead of having to retype this whole thing, above your enter button is an entry button. And if you go second, enter, it automatically retypes what you typed one time before. If you keep doing it, it keeps going back. So I can keep going back for, I don't know, 25 times. We're not going to find out how many it's got built into there. But I just want to go back. Oh, I just want to go back once. Here. Second entry, second entry. I want to get that answer that I had from before. If you have a newer calculator, you can also get that answer back by clicking up till you get to your answer, pushing enter, and it will retype it for you that way as well. The reason that's handy is because now I can just go over to that plus sign and change it to a minus sign. And I get my second answer at -2.79. So our quadratic formula, once we type it into our calculator, tells us two different answers for tan. And I'm going to write them out separately here. I'm going to say tan of theta could equal 1.79, or tan of theta could equal -2.79. And I'm going to put dot, dot, dot after that to remind myself that I'm not going to round early, that I'm going to keep all of my decimal places right until the end. So for 1.79, even though it's bigger than 1, that's okay for tan. We're going to need to find our reference angle. We find our reference angle by doing tan inverse of the positive value. So I go to my calculator, can go second tan inverse, and the newer calculator, I can go up and type it, select it from there. And I find out that my reference angle is 1.06. If that's my reference angle, here tan is positive, so it's going to be in quadrant 1 and quadrant 3. So in quadrant 1, it will be identical to our reference angle. In quadrant 3, I'd have pi plus my reference angle, 4.20. So those will be the two answers for our first tan value. For our second tan value, again, we're going to need to find our reference angle. Again, we do tan inverse of the positive value. So I go to my calculator, tan inverse, have to go up. Now, when I select that, it's going to have that negative in there. So I'm going to have to go back too far, and delete that negative out. And now we get a reference angle of 1.226. So our actual angles here, well, since tan is negative, we'd have to look in quadrant 2. So that would be pi minus our reference angle, 1.91. And we would have to look in quadrant 4. Oops. Quadrant 4, it would be 2 pi minus our reference angle, 5.06. So here's an example of where you would use the quadratic formula. They introduced the quadratic formula on your formula sheet about 2 years ago. Since they introduced it, almost every year they've tried to put a tan, sine, or cos question that has used the quadratic formula, just so you feel good that you've used that formula on your exam. So these questions have shown up quite a bit in the last couple of years. Not quite a bit, like once per exam.